Let's calculate the derivative of x cubed using the definition of the derivative. Now, there are several different equivalent forms of the definition of the derivative. In this case, we're going to use this version. F prime of a equals the limit as x goes to a of f of x minus f of a over x minus a. So this gives the derivative of the function f of x at the specific point x equals a. Now you'll see very shortly why I've chosen to use this particular form of the derivative. It's going to make our algebraic work a little bit easier in this case. So let's go ahead and apply our function to this definition. So f prime of a for our function equals the limit as x goes to a. In our case, f of x is x cubed. So I have x cubed minus f of a, so that's just x cubed evaluated at a, so that's a cubed over x minus a. Now at this point, it's going to be really helpful to remember a specific factoring formula, and that's called the difference of cubes formula. And this formula is going to be helpful for you a lot in the future, so I really recommend trying to memorize it. But this is what the formula looks like. So this is a formula for the difference of cubes, and it goes like this. X cubed minus a cubed equals x minus a times a quantity, x squared, plus ax plus a squared. You can use this for any two difference of cubes. So I'm going to now apply this formula to the numerator of my limit where I have a difference of cubes. Okay, so this turns into the limit as x goes to a of, on the top, x minus a times x squared plus ax plus a squared. And that's all still over x minus a. So I think you'll now see why this difference of cubes formula was so helpful in this case, because factoring the numerator in that way allows me to see that I have a common factor in the top and the bottom that can be canceled out. This x minus a factor, and then we have the limit as x goes to a of x squared plus ax plus a squared. Okay, now before, a few steps ago, if I had tried to evaluate the limit by plugging in a, I would have gotten as an answer 0 over 0. So that's why I went through all this algebra. But now I've reached this polynomial form, this quadratic form, x squared plus ax plus a squared, and this is continuous at a. So now I can evaluate the limit simply by plugging in a for x. So if I do that, I get a squared plus a times a plus a squared. So this is essentially 3a squared. Okay, so what have we discovered? We've discovered that f prime of a equals 3a squared. Now, you'll see now why I used this form of the derivative, this f prime of a form. The limit as x goes to a. That was so I could use my difference of cubes formula. So I've evaluated the derivative at the specific point x equals a, but we can generalize it just to any x in general. So the general form then would be that the derivative with respect to x of x cubed equals 3x squared.